Hi everyone. In this chapter 10 on application of integration, we will actually be going through definite integrals as well as more applications of integration like finding the areas under the graph as well as volumes or revolutions. So in this video clip, the first video clip on this chapter 10, I'll be going through definite integral. Okay? In definite integral, we know that in the previous chapter where we actually learned that whenever we integrate small fx, okay, we obtain a function, big Fx, plus the constant c. For example, if we integrate 1 over x, we'll get ln modulus x plus c. Right? In this video clip, we're going through those situations when there is a definite integral. That means you're integrating fx from, say, a particular value a to another value b. In that case, what we will do is that we will first find the indefinite integral, okay, and then you substitute the two limits inside. So our final answer will be capital FB minus capital FA. Just a quick example. Suppose we have to integrate 1 over x dx from x equals to 2 to 5. In that case, will be ln of modulus x from 2 to 5. And that will give me ln of 5 minus ln of 2, and hence is ln 5 over 2. You might notice that we didn't consider c in the working of the definite integral. Reason is because if you have a plus c here, and you sub 5 into this value of c, it will still be c, and you sub 2 into c, it will still be c. So the c will naturally cancel out. So all the arbitrary constant that we have in the indefinite integral would not be required to be shown in the case of computation involving definite integral. Okay? Now there are some properties of definite integral that you need to know. The first property is if you're integrating fx from a to a, of course, that will give you 0. That, of course, will give you 0. A simple proof easily show that when a and b are the same value, these two values will be the same, and hence it becomes 0. And the other one says that, the second rule says that when you integrate from a to b of fx dx, okay, it is the same as a negative from b to a fx dx. Okay. So sometimes we may want to switch the limits of the integral, and when you switch the limits of the integral, it actually differs by a negative of each other. Okay? And the third rule says that if you have integrating from a to b of k fx dx, you can still take out constants that's not affected by x out from the integral in this manner. This rule, of course, is the same for the case when it's the indefinite integral. Okay, you can always take out a constant out from the integral. And the fourth one says that we can actually split up a definite integral into two parts, or more than two parts as well, as long as the b is the same for both. Okay, so that is the other rule. So let's go through an example that is shown on your handouts now. This example basically looks into the integral of a function that involves modulus. Okay. So in this case, it says that a is a real number, positive real number, and we want to find, right, the integral from 0 to 4a x squared minus 2a squared dx. Okay? Giving your answers in terms of a. So in other words, you cannot use your graphing calculator to evaluate this integral. Okay? So what you have to do is to first identify how does this graph looks like. Okay? You do not really need to graph GC to help you to sketch this graph, because it's something that you are very familiar with. It's actually just a quadratic curve. y equals x squared minus 2a squared. So that means the curve will look something like that. Okay, and this minimum point, okay, the y-intercept is minus 2a squared. And of course, this value here is root 2a, and this value here is minus root 2a. Okay, so this will be actually the curve y equals x squared minus 2a squared. When you take the modulus of this curve, actually it becomes as follows. The portion that is below the x-axis flip up like this. Okay, and the portion that is above the x-axis, we can leave it as it is. So our aim is basically to find the integral from 0 to 4a of this value here. Right? So that means we are looking from 0 to 4a, somewhere here. Okay, 0 to 4a. We know that from 0 to root 2a, okay, 0 to root 2a, the curve is actually this part of the curve, because we are talking about the modulus. And this part of the curve has equation given by y equals 2a squared minus x squared. Whereas this part of the curve is actually y equals to x squared minus 2a squared. So you can actually split up this integral into two parts, from 0 to root 2a, okay, modulus of x squared minus 2a squared, plus from root 2a to 4a, modulus of x squared minus 2a squared dx. Okay. Now this basically is making use of the law number 4, which talks about splitting the limits. Okay. The usefulness of this splitting of limits is because in this integral, the modulus function can actually be replaced by 2a squared minus x squared. Okay, the reason is because from 0 to root 2a, the modulus function is actually 2a squared minus x squared. Okay, and then the other part, from root 2a to 4a, okay, this function is always positive. So we can remove the modulus immediately, dx. Okay. And now we will integrate each term, okay, separately. And we have 2a squared is a constant. We integrate with respect to x, you get 2a squared x, minus integrate x squared, become x cubed over 3, from 0 to root 2a. And the second one is integrating this one, become x cubed over 3 minus 2a squared x, from root 2a to 4a. Okay. Then you put in the root 2a into the x values, minus you put a 0 inside the x values. Likewise over here, you put a 4a into x values, minus you put a root 2a into the x values. So what will we get? We obtain 2a squared times root 2a, okay, minus 2 root 2a cubed over 3. You sub 0, it will be 0. And then you put 4a inside, it will be 64a cubed over 3 minus 2a squared times 4a inside, minus, sub in root 2a inside, it becomes 2 root 2a cubed over 3 minus 2a squared root 2a. Okay. So a quick simplification will give me 2 root 2a cubed minus 2 root 2 over 3a cubed, okay, minus 60 plus 64 over 3a cubed, okay, minus 8a cubed minus 2 root 2 over 3a cubed, and plus 2 root 2a cubed. Okay. So 64 over 3a cubed minus 8a cubed becomes 40 over 3a cubed. Okay. 2 root 2a cubed plus 2 root 2a cubed, of course, is 4 root 2a cubed. Minus 2 root 2 over 3a cubed minus 2 root 2 over 3a cubed becomes minus 4 root 2 over 3a cubed. Okay. So simplify these two, becomes 8 root 2 over 3a cubed. And this, of course, giving 40 over 3a cubed. Okay. So this will be, of course, the answer to the definite integral. So it will be exact values in terms of a. Okay. I hope you have understood how this problem is being done, because we cannot use the graphing calculator in solving this type of problem. Thank you.